Good morning, everyone. My name is Vikash Ranjan, and I am Assistant Professor in the college HIT, Haldia Institute of Technology. And this is the first video lecture for the subject Electromagnetic Theory. And here you can see that in Module 1, we are going to study about review of vector calculus, under which we have to study about different coordinate systems and information, and we have to study about introduction to vector calculus, under which we have to study gradient, divergence, and curl operation and all those things. Okay, but before starting, let me give some uh, a brief introduction about what is vector or vector quantity and scalar quantity. Okay, so most of the quantities, let me write it. So most of the physical quantities, most of the physical quantities are categorized into two groups. Either they are scalar or they are vector. Okay, means either they are scalar quantity or they are vector quantity. So what is a scalar quantity or what is simply scalar? So any physical quantity which can be completely described by its magnitude is called scalar or scalar quantity. Few examples are mass, then temperature, electric charge. Okay, so this was the definition of scalar. Any physical quantity which can be completely described by its magnitude is called scalar or scalar quantity. And example are mass, temperature, electric charge, etc. There are large number of and number of examples will be there. We are citing only three examples. Okay. Now, what is vector? Similarly, the definition will go like this: any physical quantity which can be or which have both magnitude as well as both magnitude and direction will be called as vector or vector quantity. Okay. Examples: velocity, Acceleration can also be one of the example. Then in terms of electric field sector. These are three examples. So let me read the definition of vector once again. Vector, what is vector? Any physical quantity which have both magnitude and direction will be called as vector or vector quantity. And three examples which are cited are velocity, acceleration, and electric field. Now, how do we represent a vector? A vector is always represented by a line segment, okay, with an arrow with an arrow at its top. Okay, this is the way we represent or representation of a vector. Okay, here the length will give you the information about the magnitude of the vector. Okay, which is scaled accordingly, and the arrow, this arrow is there. This arrow this arrow will give you the direction. This arrow will give you the direction. Okay, this is how we represent a vector. Okay, now for example, if I want to write a vector quantity, or there is a vector called a vector, so we represent a vector like this, means a and an arrow on its top. Okay, this is the representation of vector a. This tells us that this quantity is a vector. Okay, now we will learn few different types of vectors. One is null vector. So what is null vector? This is any vector with zero magnitude is called as null vector. Okay, we can also name it as zero vector. Okay, and the name says that the magnitude is zero. So when we represent such type of vector, so we cannot represent a null vector with an arrow like this. Okay, because arrow, or the length of this line segments, it represents the magnitude of the vector, and since this null vector has zero magnitude, so this is the only vector to which we cannot use this symbol. Okay, this vector symbol. Now the second vector which is important is unit vector. Okay, so what is unit vector? A new kind of vector. So the vector whose magnitude is unity. Okay, whose magnitude is unity is called as unit vector. Okay, is called as unit vector. So any vector whose magnitude is unity will be called as unit vector. This vector is mainly used to give the information of direction. Okay, it tells you in which direction the vector is moving. Okay. So how do we represent a unit vector? A unit vector is represented like a cap. Okay, if I say that a cap is a unit vector, means a is a unit vector, then I will represent the vector a is in this fashion. I will draw a cap on the top of a. Okay, this is unit vector a, and this vector doesn't have any magnitude. Sorry, this this, uh, this vector will have unity magnitude. Null vector do not have any, or null vector doesn't have any magnitude. They have zero magnitude, but unit vector has unity magnitude. This is a unit vector, and it gives you the information of the direction. Okay. Now any vector, okay, any vector can be represented using a unit, can be represented by a unit vector. For example, there is a vector a given to you. Okay. So this vector can be represented in this way. A A cap. Okay. The mod of A vector will give you, what it will give you? It will give you amplitude. Okay. And A cap will give you the direction of vector A. So as as I have told the definition of a vector will, or a vector is that quantity which has both magnitude plus direction. Okay. A vector is a quantity which has both magnitude and direction. So if A is a vector, and I am telling that A is a vector, so from this expression we can see that it has a magnitude, which I have written amplitude over here. Same thing. So it has a magnitude of mod A, and the direction which is given by the which is given by A cap. Okay. Now, how to find out the expression of unit vector? So from this equation only, the A cap will be given as vector A divided by mod of vector A. Okay, mod of vector A, very important for, sorry, very important formula. So to find a unit vector of any vector, what you will do? You will take that vector and you will simply divide that vector with the with its mod value. Okay. Now coordinate system. So here we have studied about or seen about what is scalar, what is vector, then null vector, unit vector. Now coordinate systems. So in this module, we are going to study about three coordinate system. First one is uh, rectangular coordinate system. The second one is cylindrical coordinate system. And the third one is spherical coordinate system. Okay.